Hello viewers, welcome back to my channel. In today's video, we will go through step by step a SAS program that generates a lab shift table. This table is essential in clinical trials to analyze how lab parameters change from baseline to post-treatment across subjects in different treatment groups. So let's get started. Let's understand the output, what we want for the lab shift table first. So in this lab shift table, which we will be working on, the output will be like this. Right now, I'm also showing you the values also, but if you see the mock shells, instead of the values, you will have the value as XXX being marked, or its masked value to mention that this is a mock shell. So according to the mock shell which I have used for this study, what I have to generate is that in lab shift table, the first column will give the information about the treatment and in brackets the number of big N, that is the big N count here. This is the big N count number, and I have masked the treatment as the treatment A, treatment B. Then comes the lab parameter about which the data is being displayed. So in this video, I have used two parameters. One is hematocrit and the other one is hemoglobin. Then next is the analysis visit as a column. And here I have used three visits, visit 0, visit 1, and visit 2. Visit 0 is also a baseline visit. So from the baseline visit, I have got all the baseline values, whether the eval value of the particular test values fall under the normal range or is it low, high, or missing. And in the next column is giving the information about the analysis normal range indicator for the respective visits and param CDs in comparison with the baseline visit. So when I say the normal, high, or low, missing, in this case, it is the values for the analysis normal range indicator. And this column is the values having the information of baseline, normal, low, high, missing value. So if I say for baseline normal and for the analysis normal, the value is 2, that means that the for visit 0 for hematocrit param series, there were two subjects for which the baseline values were marked as normal, and same is the case for the analysis based normal range indicator value being as normal. So both normal value is coming for two subjects for baseline as well as the analysis range indicator for hematocrit in visit 0. And similarly, the rest of values will be considered here. So now let's go to the program on how to generate this table. So for this table, I have used dummy datasets, and for dummies dataset, since from the ADSL, I only need the U-subject ID and the treatment variables. I have kept only the treatment variable, that is the numeric variable TRT01AN, and only the U-subject ID. Whereas from the lab or ADLB, whichever you are using, you will need only the parameters which will be required in this table, and those are the U-subject ID, A visit values, numeric as well as the character value, the ANR IND, BNR IND, you don't need AVAL, you need these two values, and then you need the param CD and the parcat. So using these 5-6 variables from the ADLB or lab data, you can generate the lab shift table. Now let's go through the program where we have written a code to generate this table. So first of all, what we have done is that we have sorted the input data set, that is the LB and the ADSL variables, by the U-subject ID, and the if for LB, I have used the U-subject ID, parcat, param CDs, and the result variables. Now, since I want to get the value of my capital N, and capital N or the big N, we can get the values from ADSL, I'm using the proc SQL function or the proxy code procedure here to get the number of subjects for treatment 1 and treatment 2 coming from ADSL and creating a macro variable out of it using the into semicolon functionality of the macro variables. So in this way, if I run this, let's run this till this and see the result. This will be the sorting only, but mainly what I want to show you here is that how we are generating the macro variable T1 and T2 for treatment 1 and treatment 2, and what will be the values in these two macro variables. Since we use the put statement to display the values of the macro variable values, you can see that in log window, we have the values coming as 4 and 6. That means the treatment 1 is having 4 subjects and treatment 2 is having 6 subjects in ADSL. So now let's join these two datasets and get only the subjects which are present in both the dataset. So for this, what we have done is we have merged the ADSL and LB by use subject ID, and we have used the functionality where we give an alias to the ADSL as well as LB as in ADSL and in LB, and we are using the if statement here that in this case that when the record is present in both the dataset, then only it should be present in a resultant LB dataset. In addition to this, what we have done is that we have put a user warning as well to inform that if there is any subject in LB dataset, but it is not present in your ADSL dataset, then we can throw a user warning that for this subject, there is a missing treatment assignment for subject in ADSL. This check allows to make sure that all the subjects which we have in LB are also present in your ADSL dataset. So next is in the next step, we are using the normal range indicator variables. And in this dataset, what we are doing is we are converting the N, L, and H values which were present in the data to the format in which we want it to be displayed. Since we do not want to display as NL or H, we want to display as normal, low, missing, or high. We have converted the respective values accordingly, and we are also giving a numeric value for these particular characters value here. The numeric value will help us to sort the resultant data set in a proper way. When we say that we have given the normal value as number 1 and low value as 2, why we are doing is because if you see the mock, the first value which we want to display in the columns or the row section is the normal value, then the low, high, and missing. Because we want the value to be displayed in such an order, we have given the numeric values in the similar order so that it is easy to sort the final data set in the correct character value order. So similarly, we have done this for both of the variables, that is for the analysis normal range indicator as well as the baseline normal range indicator variable also. So once we have done this, the next step is to get the count, that is the frequency count values from the dataset for each respective treatment, as well as param CDs and visit for these combination of your baseline normal range indicator and the analysis normal range indicator values. So using proc frequency, we are counting how many records exist for each combination of treatment group, lab parameter, visit number, baseline result, and the analysis result. This frequency is saved in the shift1 dataset here. Let's run this program till this part and see what is happening. So let's see the LB dataset after merging. You can see we are having the TRT variable also coming from the ADSL dataset. And if we go to the lab and LB underscore table dataset where we are converting the NLH values to the respective character values, low, normal, high, or missing. You can see that is also done correctly. Now let's see the shift one table, that is the frequency table which we have just generated. So now if you see that for each treatment, that is 0 and 1, you can see there are 13 records for uh, treatment, 0 for hematocrit as well as hemoglobin, all combined for each visit. And when you see the normal range indicator value and the analysis normal range indicator value as well, you will see that we have for each visit high, normal, or low as we are having in our data, and their respective count coming as the count here. Please note that in this case, for hematocrit, taking an example of hematocrit for treatment 0, you can see that for visit 0, we only have high and normal value. We do not have low or missing value. But to display these values in our final table, what we have to do is we have to create a shell data set or a dummy data set, which will act as a placeholder for the values which are currently not present in our data. So what will happen is that when we create this shell data set, it will have the row placeholder for the uh, categories in this example, like in this case, for the low and missing categories of the analysis range. And since the values are not in the data, what we'll have is that we will populate it as 0, but we will have the placeholder for all the categories which are we have to display in the table generated with the help of a shell data set. So to generate the shell data set, what we want to do is, first of all, what we are getting is we want to get all the uh, treatments, param CDs, and the visits which we are currently having in our data. So using the proc SQL, we are generating a param data set where we are getting all the distinct combination of treatment, parameter, and the visit, and we are creating the param data set. So then in the next step, what we are doing is that we are using a macro variable again to assign the for each the baseline range indicator as well as the analysis normal range indicator. We are generating a shell data set again by the name of BNR or ANR, and we are creating a record for normal, low, high, and missing each, irrespective whether it was missing in the data or not. So this is again a shell data set which we are creating for all the categories of the normal range indicators. So let's see these data sets. So now if you see from the param, we have got the treatment, param CDs, a visit values. And if you see the ANR here also, we have created a placeholder for each respective normal range indicator where with its numeric value, and same is the case for the baseline normal range indicator as well. So now let's uh, build a shell for all the possible combination from these datasets which we have just generated. So for this, we are using a proc SQL again, and we are using a Cartesian join to create a shell dataset containing all possible combination of treatment, parameter, visit, baseline indicator, and analysis indicator. This ensures that combination without any data will also appear in the final dataset. So if you run this, you will get a dataset by the name of shell. And I'm also running the proc sort of the shell dataset as well as the shift one dataset, which we have generated in the above frequency proc frequency step, which is having our data from the study data. So let's see the shell dataset first. So if you see the shell dataset, which is our placeholder dataset, you can see that for each combination of your treatment, param CD, visit, and the baseline and normal range indicator values, you have a placeholder created. This is for treatment 1, hematocrit and hemoglobin. Now, if you go below, you will have for the second treatment also coming for hematocrit, and if you proceed ahead, you have for hemoglobin for first treatment as well, and you will also, if you notice, you will have all the possible combination being generated here in the shell dataset. So now the next step is to use this shell dataset and populate the frequency count values which we have calculated and created a shift one dataset in the respective rows here. So what we are doing is that we are merging the shell and the shift one dataset in this data step, and we are creating a shift two data, and we are merging by TRT variable param CD a visit and the BNR IND. Why BNR IND? Because if you remember when we saw the mock shell, we have the baseline column where we have the rows governed, like first row should be normal, then the low, high, and missing. So because of that, we are using the normal range indicator value as well in our by statement. So now we are using if A means that we want to keep all the rows which are coming from our shell dataset. That is the main purpose of creating the shell dataset as well. So using this functionality, we make sure that all the possible combination which does not exist in the data or is also present in our final dataset. Now comes is the next step is the step in which if there is a particular combination which does not exist in the data, but since we are keeping a record for it in our shell, we are setting it to count 0. So that is the case here, that if it is present in your A, which means it is present in your shell dataset, but it's not present in B, which is our shift dataset, then the count variable, which we have the count of the frequency, that should be populated as 0. Otherwise, in the otherwise, if it is in the second dataset and it is also in the first dataset, then the count variable will have the value of count coming from the shift one dataset. Since we do not need the percent data column coming from the shift one, we are dropping that variable. So let's, in this way, we are generating the shift two tables and we are sorting it by the respective treatment param CD visit PNRI and the variables. And here, if you notice, we are using the numeric variable to sort because we have already given the normal as 1. If we will not use the numeric variables, if we used the character variable for the normal range indicator, then it will be sorted in the alphabetical order. So now let's run this and see the result. So this count variable was the variable which was coming from shift one dataset, and CNT is the variable which we created in our shift two variable, shift two dataset. So now if you see the combination which was not present in our data and hence the count was missing, what we are doing is we have populated the count as 0 for those cases, and for the remaining where we do have data in our dataset, we are getting the same values from count to CNT variable. So you can see that for each combination, you are either having a value of 0 or the values which is coming from the dataset being populated in a shift two dataset. So now if you see now here, now the thing is all the information is coming in your row basis, but what we want to display in our table is that we want to convert the ANRIND variable information, this information as columns in our table and not as rows. So what we need to do is we need to transpose this data set and to get each ANRIND value as a column value with its count of subjects as its row values. So to do that, what we have done is we are using the proc transpose on the shift two data set and generating a shift three data set where we are converting the count values in as the var statement, and we are giving the ANRIND variable numeric ANRIND variable as our ID variable to make sure that this variable value comes as the column value, and we are using the prefix also in this case. So let's see the resultant of proc transpose. Now you see that the ANRIND value, we have given the numeric ANRIND as the ID variable, and prefix we have given as ANRIND. So what is happening is that when we were converting the rows to column for the ANRIND, the resultant columns have a name of prefix ANRIND along with its numeric variable value, which was 1, 2, and 3. So the resultant column names comes as the ANRIND1, ANRIND2, and so on. Now you see that for since we have only converted the analysis normal range values, you can see that the BNRND values are coming as it is in your rows, and we have the count coming for analysis range indicator values as the column values here for each possible combination, which is the desired way in which we want the data to display it in our table. So till now, what we have done is we have the wizard column, we have the baseline column, we have the respective analysis analysis range indicator columns. But what we are still left with is the first column in which we want to display the treatment and its big N value. So for that, what we have to do is we have to create the another column in this shift 3 data set, and that can be done is that since we do have a TRT0 and AN data set, what we are doing, we are using this variable information, and using the if statement, we are creating a new variable by the name of TRT. And since we have already created a T1 and T2 macro, which is capturing the value of the big N from our ADSL, we have created a column TRT by this combination. That is that if the TRT01 AN is 0, then the TRT variable have the value of TRT colon TRTA and in brackets the count of the big N values for TRTA. That is the number of subjects assigned to TRTA, and similarly when the TRTAN is 1, we have the value for TRTB. So in this way, if you see the FIN dataset here, you will have a TRT variable also being created, which will have the value like this. Since I have used the dummy variable here, so I have given a TRTA and TRTB. But when you will use this in your own study, what you can do is you can concatenate your TRT01A value or whichever value you have, the proper description, this is the numeric value, the character value of the TRT. You can use that information variable and concatenate that information in this step, and you can get the same desired result as well. So we have run this data set, and now the next step is that if we want to generate the page number as well in our RTF file, that is the last step we want to do. So to generate the page number, what we have done is that I am increasing the page number for each new record for the visit and values for each new param cities here. So because of that, what I have done is I have generated a FIN2 dataset from my FIN dataset, and using the by statement, I am first mentioning that since I want to use first dot, I have to give a by statement also in which it should be considered. So using the by statement, I have given that it should consider TRT variable, param city, a visit, and variables in the sorting order when it's the fin dataset is being set to generate the FIN2, and using the retain function, I am generating a PG variable and assigning its initial value as 0. Now, when it will read the records in the dataset, if the record is being read for the first visit for each param series, then the page number value will be incremented by 1. Otherwise, it will remain as same. So if I run this data set, what will happen is you will have a new column by the name of PG, and it will have the value incremented by 1 for every new visit occurrence for each param series. So now if you see that for hematocrat, which was my first param CD here, for visit 0, that is the first visit for this hematocrat, I am having the value of PGS1. And when there is a change in visit for hematocrat uh, param CD, again, this is the first occurrence of visit 1 for hematocrat. The page, not the page, the PG variable is being incremented by the value of 1, and it is coming 2, and so on. You can see that this PG variable is incremented by 1 for each new occurrence of the visit for each param CD. So this is our resultant data set, where we have all the variables which we want to use in our final proc report to generate the RTF file in the proper format. So now the next step is to generate the RTF file using the proc report. Again, to generate the RTF, we have to use the ODS statement. So I have in the ODS statement, I have given the RTF file path and this styling of the output file which I want to generate. I have given the escape character as the blank, and then I have used the proc report uh, step to generate the RTF. So in this proc report, what we have done is we are including the treatment label, lab parameter, visit number, baseline results, and count of subjects whose lab results shifted to normal, high, low, or missing after treatment. This proc report is also having the title information, that what is the title we want to give, and even the footnote which we want to give in this report. So what we have done is, using the compute statement, that we have inserted a blank line after each new visit is being displayed in our data. So for that, what we have done is we have used the PG variable which we have created, that for each new value of PG, there there should be a blank line inserted after each row. So using this functionality, we have generated the RTF file. So now let's run this ODS statement and see what is the output generated. First of all, since we do not have printed no printer for proc report, we will see the result of the RTF file also in our result window. So if we go through the result window, you can see that we have the values populated in the desired format. So in the first column, we are having the treatment along with its capital N value. Then we have the parameter, visit, baseline values ranges, and the analysis values ranges also, and their respective values. You might see that the visit, lab parameter, or the treatment values are occurring only once for these grouping. Why it is happening is because we have used the group function here. If we change it to display in this format, then it will be populated for each row here. So if we run this, let me show you the RTF first, which we have just generated. So this was the initial one which we had generated. Now this is the one we have generated from our code, and you can see that it is same as what we have seen earlier. And here you can see a blank line included after each, before and after each visit. And we have, since we have used the grouping functionality in the proc report, the values which are same for next rows are coming only once. But if you want to display this value for each row here, then what you can do is you have to use the display functionality here. And if you run this, let's run this again and see the result. Here you can see the difference that after changing the group functionality from to display, you are getting the visit, lab parameter, and treatment values populated for each row. And again, let's go to the RTF file for this one. You can see here that the respective values are populated for each record now. So depending on your requirement, you can make the changes and generate the RTF file. So in this way, you can generate the RTF file for the lab shift tables. You can do further modification as an required in your study. Like for example, if in case you do not want the param CD in your table, but as a page header, then accordingly you can do that as well. So that's wrap our detailed explanation on how this SAS program creates a lab shift table. If you find this explanation helpful, please give it a like and subscribe to my channel for more SAS programming tutorials. Thanks for watching. Let me know in comments if you want me to cover any specific topic.